Okay, so today we are going to be learning about modification of quadratic equations algebraically and graphically. All right, so before we get started, students should be able to answer the following essential questions. Now, this is kind of a review from older classes, older algebra classes where you learn about translations and reflections before we get to quadratic functions. So, before we get started, what is a function? Where do we find the solutions to functions on a graph? How do we modify a function? And what does it mean for a function to be modified? After the lesson, students should be able to know or understand how to modify a parent function graphically, how does a parent function modification change an algebraic function, and how do we interpret the effects of transformations of functions. So, I mentioned the word parent function. What is a parent quadratic function? Well, the parent function of a quadratic is the function f of x equals x squared. And that is just a parabola centered at the origin with the vertex 0, 0. Now, typically that is not what we are given in quadratic equation. Usually, well, we modify it. So, another way to represent a quadratic equation is general form. What is general form? Well, general form is the function f of x equals a, which is a constant coefficient, a times x squared, it's our quadratic term, plus b, another coefficient constant, times x, our linear term, plus c, another constant. Now, we can see modifications done to a function in general form, but it's a lot harder to see that than it is with, say, standard form. Another way to write a quadratic function. So a quadratic function can be written in standard form. F of x equals a, which is our coefficient from the first form, general form, a times x minus is important, minus h squared plus k. That can be a plus or a minus k depending on our translation. So, how is it easier to see the translations, the modifications in standard form? How is it so much easier to see that than it is in general form? Well, that's because we have our vertex is the equation, or not the equation, but rather the point h comma k. Now that is the vertex of any parabola in standard form. And we use the standard form equation to find the vertex much more easier. We find it using the standard form equation rather than the general form equation. So what do the coefficients, the constants, mean in standard form? What does a, what does h, and what does k stand for? There are modifications. What is a? A represents our compression or stretch. So, say we have an a value of 3. So with an a value of positive 3, we are going to be compressed. Our function, our parent function, f of x equals x squared, is going to be in standard form. We'll get there. Just know that the a value, 3, is going to be compressed. We're getting narrower. The function narrows by a factor of 3. But say we have Now a factor of 1/3. Now, with our factor of 1/3, we make the function wider by a factor of 1/3. So that is important. That's a translation. That's a change to our that's a modification to our parent function. So now we have h. H is another way we modify our function. H is a modification or translation left or right. On the coordinate plane. Now we need to be careful with our h value. So remember how I said that the minus sign in x minus h squared is important. So this is where a lot of people get tripped up. Whenever we see x minus h, we try to exclude h from the minus sign. We try to think of it without the minus sign. So say we have the example f of x equals x minus 3 squared. Now here we see our h value is 3. It's positive 3 because we kind of turn a blind eye to that minus sign in there. We do that because now with this example, say we have the example f of x equals x plus 3 squared. Now you may think that h is positive here, but h is actually negative because we added the opposite. So we basically changed from x minus 3, well, we made it x plus, or x minus negative 3. So f of x equals x minus, there's a negative 3 hidden in there, negative 3 squared. We added the opposite. So when h equals positive 3, we're translating 3 units, whatever units you're using, 3 units right on the coordinate plane. And if our h is negative 3, h equals negative 3, we're translating, you're translating 3 units left. Okay. Now we have k. So what is k? K is a translation up or down. Of our parent function. So say we have the function f of x equals x squared plus 5. Now notice I didn't write this quite in standard form, but since we don't have an h value, our h value is 0, we can rewrite this so I can show you what I mean. F of x equals x minus 0 squared plus 5. So with that plus 5, we are raising the function up 5 units where its vertex is 0, 5. So we're up on the y-axis at the point 0, 5. At this point, I would have students practice some problems and collaborate with other students. So now we're going to see how we can write our parent function in standard form. Because if we write our parent function in standard form, we can see how our modifications, our translations are, well, we aren't modifying it, we aren't translating anything. So remember, our parent function is f of x equals x squared. So now we're going to try to write that in standard form. So f of x function equals 1. 1 is our a value. If if our a value was 0, we wouldn't have a function. The function would just be 0. That's a rule of multiplicative identity. 1 times x minus 0, because we're translating 0 units left or right, minus 0 squared plus or minus, because we're not going up or down, 0 units. So you can see we have transformed our parent function into the standard form. Now after this, we are going to consider the example. Say we have the example f of x equals 3 times x minus 3 squared plus 1. So before we try graphing this on our calculators, what are our modifications? What can we see algebraically that our modifications are? Well, right away, we see our a value equals 3. So what does that mean? Our function, our parabola, is compressed by a factor of 3. We see that our h value, what is our h value? It is positive 3. Careful again with that minus sign. H equals positive 3. So we are translating 3 units right. We don't know right from where. We don't know where we're translating from, but we'll get there. And we see our k value, k equals positive 1. So that means we are translating up 1 unit from where we start, where our parent function is, 0, 0. So where is our vertex? How do we find our vertex again? Our vertex of this function, this example, focus here, the vertex of our function, here, let's just get some things out of the way so we aren't confused. The vertex of our example function equals the point h comma k. And what is our h? H is 3, positive 3. What is our k? Positive 1. So our vertex of our example function should be at the point 3, 1. Now, we can see this on our, change screens. We can see this on our calculator. Well, hold on, I didn't graph it yet. But we can see our parent function here I have graphed. We can see that our vertex right here is at 0, 0. So this is our parent function, f of x equals x squared. So now we're going to graph our new function, 3, remember 3 times x minus 3 squared plus 1. And we can see here that we have modified our function. We have translated it to the right 3 units from the origin and up 1 unit from the origin. So now our vertex, like we said, is at the point 3, 1. Now we can see that our new function, our example function, is skinnier than our parent function. That's because we compressed it by a factor of 3, like we said. So that is about all we have in our lesson today. Thank you.